everyone, my name is Rose and today I'll be discussing question number 3, which is the true and false section of the midterm. This section was pretty easy, but because they were all false, I found myself second guessing everything. But going to the first two questions, which are involving compound X, the two statements are slower than benzene if it were to react in an electrophilic aromatic substitution reaction. And number 2 is that it has 8 resonance signals. Now, the obvious false one is the 8 resonance signals because it's pretty easy to find the line of symmetry here. So then it would be 1, 2, 3, 4, 5, 6. If we were to forget about symmetry, then there would be 8. But we're too smart for that, so we know that this one is false. For number 1, it says that compound X will react slower than benzene during an electrophilic aromatic substitution reaction. This is false for a couple of reasons. Because this branch is an electron donating group, it is giving electrons to the center of the benzene ring. So in fact, it would make it faster than, say, a benzene that doesn't have the electron donating group on it. So this is why this is also false. Compound Y, we see that the two statements regarding it is the 6 pi orbitals and the stronger base than diethylamine. Starting with the 6 pi orbitals, this one's pretty easy to figure out. There would be one here, one here, one here, one here, and one here. 1, 2, 3, 4, that's 5, not 6. I'm guessing it could be a little bit confusing because nitrogen only has 1, but you could mix up and say it has 2, but there's only one little docking station for that pi orbital over there. Moving on to the second one, this one's a little bit more complex. So what I like to write down when I see stronger base, a stronger base means that it's less stable. So keeping this in mind, let's check the aromaticity of this molecule. It has 6 electrons in conjugation. So that would be an aromatic molecule. An aromatic molecule is very, very stable compared to a non-aromatic or a non-aromatic molecule like diethylamine. So since the molecule Y is very stable and aromatic, it is going to be a weaker base because a stronger base would be less stable. So both these statements are false. Compound Z, the two statements are 4 signals in NMR, and there is no Diels-Alder reaction that can happen with this molecule. Starting with the 4 signals, there is a very obvious line of symmetry. There are 2 hydrogen groups on each side. This molecule would have 2 signals, not 4, because of the line of symmetry. The no Diels-Alder confused me a little bit, but this is an electron donating group, and this obviously has 4 pi orbitals. These all indicate that this is a diene, so it can obviously perform in a Diels-Alder reaction. There's no reason for it not to. Another little trick that I got to confirm this is that in question 1A, the diene looked pretty similar to the one that is given here. So there's no reason why this would be true. So these are both false. Thank you for watching.